Hi, I'm Jay Faulkner. I'm an open source developer with G Research Open Source Software and the security liaison for Ironic as part of the Distributed Project Leadership Team, or DPL. I wanted to take a little bit of time today to talk to you about the ongoing 2026.2 Hibiscus development cycle. So as you're probably aware, OpenStack releases 2 integrated releases per year, usually suffixed with a .1 and a .2. And we split our development cycle similarly up into half-yearly segments. So at the beginning of each one of those, we have what we call a project teams gathering, or PTG. And during that PTG, all of the developers who spend their time working on Ironic, the operators who operate it, we all get together, talk about pain points, talk about in-progress items, maybe try to figure out what's next. And I wanted to sort of take the time to take our document here, which has been provided, our work items document, that'll be linked in the description, and go through it and walk you through some of the things here, give you maybe a little bit of context. As always, the real information is in the documentation. So, if I say something that sounds not quite right, please go check that doc for validity. The other thing I want to mention is that these are items that are in progress. We're starting work on them now. We're not making any promises at all that they're going to get done this cycle. Ironic developers, we're pretty busy people. We've got a lot of things going on, usually a combination of upstream and downstream responsibilities. So we try really hard not to make promises we can't keep, which usually means making no promises at all, except for our stable support promises. So keep that in mind. If you do want to hear information about features that are already done and ready for you to use, we had an Open Info Live talking about our 2026.1 Gazpacho release recently, and I'll make sure that's linked down in the description below so that you can find it. But let's get started and let's talk about what's going on. So as you can see in this doc, we've got, sort of a collection of features. We categorize them roughly into maintenance, bug fix, or feature. Sort of maintenance is something that may not be a bug. It may not even be something that you as an operator would notice, but it's something that we know we've got to do this in order for our Ironic to keep working. Maybe it's supporting a newer distribution or newer Python version, or maybe, it can be really anything that, has a ticking time clock on it, and we've got to hit that deadline in order to make sure Ironic will keep working. So those are maintenance items. The bug fix items are more direct. There's something that's broken and we want to make it better, but not necessarily add new functionality. We just want to make your life a little bit better. And then features are, of course, things that didn't previously exist that do now. It's worth noting that Ironic, we're a back-end process. We do a lot of work that you don't see. So even something that we might classify as a feature, you might not necessarily see it as a feature, but we're talking about things that like add new functionality to an API, for instance. And we're going to start with one of those right now. This is a pretty good internal example of deferred tasks. All right. So with our deferred task goal, the idea here is that, if you've been following along with OpenStack development, you know that we're in the middle of an eventlet migration. Ironic actually completed that migration 1 or 2 releases ago and stopped having a hard dependency on eventlet. However, we're seeing now in the wild that this can have some weird performance hits. And one of them here is that we have a tendency to call sleep in conductor threads. And I know that seems like a crazy thing to do. If you're a software developer, you're going, wait a second, why are you calling sleep? Well, in the eventlet world, a sleep was a kind of a form of a yield as well, because you're using green threads. So if we said sleep, it just meant eventlet would go put that on the shelf over there for however long you're sleeping and focus its attention on doing work in other parts of other green threads that were actively running. For Ironic especially, this is impactful because we kick off a lot of long-running items, such as telling a BMC to do something and then maybe waiting for it to get done, even if that might take 5 minutes, 10 minutes, however long. These can be really long-running. And with eventlet, we just sort of were able to let the thread hang out because it's a green thread and it was cheap. But now with the actual threading, with doing actual Python threads, obviously each thread has a much larger memory cost. And so we need to work out these situations where we're hanging up an entire thread while we're waiting for something to happen. So what do we do to fix this? Well, The idea here is that we're going to introduce a concept of deferred tasks at a high level in Ironic. So our initial milestones are going to be really laser focused on those performance issues that have come up that I mentioned. But the idea here, I believe, is we're going to end up with an API endpoint that you would be able to call and view tasks that Ironic has in its to-do list, so to speak. Look at those, maybe even have some states attached to them or some metadata that makes it a little bit easier so that, right now, I always like to say that we have decoder rings in Ironic, and that's where you sometimes have to have special contextual information to figure out what's going on. And one of those sometimes is when you look at a node, trying to answer the question of what exactly is Ironic doing to that right now can be hard to answer. And, maybe one of the things we're going to be able to fix with this is if we break out those tasks, put them somewhere else, you'd be able to read details about the tasks that Ironic's doing, how long it's taken, stuff like that. This is a feature that I expect is going to be on this list for multiple releases. Because like I said, we've got, an idea of milestones here. We want to fix the issues and then slowly introduce an API and give us some scaffolding to do more interesting things. But this is going to be a pretty big, beefy change in Ironic, and we are going to be very, very careful to make it as transparent as possible in terms of functionality while making sure that things are going fast and working well. All right, so that's deferred tasks. The other one here, and this is another one that is very much performance related, very much an attempt to improve the status quo. Well, is Nova Compute startup performance. So if you're not familiar with the overall architecture, if you type OpenStack server create, and that goes and talks to Nova and tries to get a machine established for you, an instance provisioned, Nova has multiple backends. So, you might be asking for a virtual machine, in which case maybe it's reaching out and it's configuring a libvirt VM on the hypervisor. Well, this is the same point that Ironic plugs in. So if you say you want to provision a machine and it ends up being an Ironic bare metal server, that Nova Compute is sort of the interface between the nodes, the servers that Ironic's managing, and figuring out their state and feeding it back into Nova. We made some improvements recently, which allows for easier horizontal scaling of this service so that you can make the absolute number of nodes managed by a given Nova Compute as small as possible. Part of the impetus behind this is that at certain numbers of scale here, when you've got, hundreds and hundreds of nodes, maybe 1,000 plus nodes being managed by a single Nova Compute, a large number of performance issues start cropping up. These include things like the service itself taking multiple minutes to start up, including reports in the wild for as long as 15 minutes plus to get a service started and ready to service customers. Things like syncing of information from Ironic taking longer to come through that compute. So let's say you have a node that finished cleaning, it gets kicked over to available. It might take Nova a little longer to figure out that's available than makes sense. And so these are all sort of, I don't know if this makes sense or not, but there are a lot of small performance things that have added up over time. And so what we've done is we've worked with the Nova core team. I'd like to thank Sean Mooney over there. Myself, Doug, Sean, we're all going to be working together on an Ironic Nova working group to improve startup performance. And we've already found some major wins here through some minor benchmarking where we found something that's running at big O of n squared that we have a patch up right now under review to lower it to an O of n. So like real beefy performance improvements without having to give up anything on the other side. Now, I don't think this is going to clean up all the issues for people. We've got a lot here, and we're, similar to before, we're going to take a multi-staged approach. The first approach is going to be to grab all of those low-hanging fruit, pluck them off the tree, and hopefully backport them whenever they're transparent. And so these will be things like, that quadratic speed thing that we found running in the provider tree. We can take that, fix it. As long as it's transparent, we can get it backported to earlier Nova versions. So even if you're a person who's not planning on upgrading, you might have some performance improvements coming to a stable branch near you soon, or at least I certainly hope so. Additionally, we're going to be adding a CI job that benchmarks this. We're going to have an idea of this Nova Compute startup performance being a key thing that we're targeting and we're tracking. We found that having a built-in benchmark that you can run in CI is incredibly helpful for these things. We had a situation Oh my gosh, at this point, it probably was close to 6+ years ago where we had one of our API endpoints, V1 nodes, which is what Nova Compute calls, returning things very slowly. And we did a big optimization push in Ironic. We built in some benchmarking to make it easier to find, and it's not recurred as a result of having that scaffolding in there. So we want to make sure we have that in there so we can have the feedback loop for developers, and we can fix the issue once and not have to worry about it regressing in the future. And then finally is right now, we feed all of our feedback directly to Nova about what's happening with Ironic nodes. And then Nova manages how those Ironic nodes end up in placement. Placement's a separate service that used to be a part of Nova, where we sort of have these resources that are available for provision. It's sort of, the big menu that maybe you could think the scheduler picks from. And if you're a Nova developer watching this, I just want to apologize in advance. I know that's probably a terrible description, but in general, that's sort of the way I've got it modeled in my head. So the third step here is going to be looking at situations where Ironic can potentially interact with that placement API directly and cut out the middleman to speed up some of these. So we're looking at this from all directions. This is another one that I would be surprised if we get this completely buttoned up this cycle, but we're going to make it better. We're going to make it better. We're going to work on it and iterate, and we're going to make sure there's a CI job and tooling in place to make it very unlikely to regress. So hopefully that'll be useful to y'all. So I'm going to move on to bulk node operations. This is one that is important. It's a useful thing. And this is because in Ironic, we've had a pain point where if you're managing a highly scaled Ironic cluster, and we definitely have reports in the wild of Ironic clusters scaled above 100,000 nodes in a single cluster. If you want to change something about the configuration of a node in that cluster, or even a class of nodes in that cluster, you're going to have to make a single API call for each node. So for instance, if you saw our Gazpacho video and you're interested in the new auto detect deploy interface feature, in order to change that deploy interface on a node, it takes a single API call per node. So you can quickly see in a world where you might have tens of thousands of nodes that making the number of API calls required to update this actually becomes a pretty significant issue. So our thought was we need a way to sort of bulk up these endpoints. And so what we want to do is add the ability to essentially anything you could query a node list for. So, you can say, give me all the nodes in this conductor group. We want to also be able to say, change all the nodes in this conductor group, for instance. Now, one of the issues that sort of surfaced through this is we were initially going to take a pass at this that might be a little synchronous, but given how locking works in Ironic, we would essentially be just pushing that do a thing in times into the API itself, and the callers just have to wait anyway. So that's not a great solution. So what we have decided here is that we want to wait until there's enough of the deferred task framework in place that we can plug into it and set all of these up as asynchronous calls that would put a task in that would get completed. And so I believe we'll make progress on this in terms of planning, in terms of ideating. I'll be surprised if we make significant code progress, but we're going to try, and it's pretty important. And part of the reason it's important is actually these two features, the bulk node operations and the power lockout tagout that I'm about to jump into, sort of combine to make a really good story around disaster recovery, where, oh no, you've lost a chiller in one of your data centers and you need to reduce the heat output by 40% in 15 minutes or things start going down. Having a bulk endpoint and combining it with the feature I'm about to describe would be a great way to have like a big red button to respond to that emergency. And one of the things I'm really proud of in Ironic is we try hard to mirror the problems in the real world and not ignore them, not try to model them away in a perfect world. We know the world's not perfect. And so, this is one of the features that we're adding to help with that, of the power lockout tagout. So if you're not familiar with the term lockout or tagout, it's common in large physical facilities like a warehouse or a factory or something, that if you're operating on one of those large pieces of industrial equipment, that you're going to do a lockout. And so what that is literally you might go over to the breaker box and flip the breaker to turn off the big machine. And that breaker is going to have a spot in it where you can attach a padlock and lock it up. And you would be the only person with the key to that padlock. So that would mean as long as you're holding that key and someone isn't taking an angle grinder to your circuit breaker, that you're physically safe while inside that machine performing maintenance. And this is kind of the idea we wanted to model for servers, that there are definitely situations where regardless of what Ironic wants to do, regardless of what an API user asks, regardless of anything, that we want a node's power state to stay where it is, whether it be on or off. And so we looked at this feature of the power lockout tagout so that, if you're a system admin, you could power a machine off and force it to stay off for, like I said, data center cooling reasons. I've even had a user come to me with the use case of maybe a billing thing of where, power the machine down, lock it off, and then go force them to go. So, I mean, this is something that I think could be very useful depending on what you're doing. However, we had a spec written for this. We had like an idea around it, but when we started talking at the PTG, it became really clear that the difference between power lockout tagout and our existing maintenance Boolean was not super clear. And that maybe the correct solution is to take the idea of maintenance and change it from a Boolean into something that's maybe more fully throated, like a list or something like that. Because, of course, it might make sense that you have a failed drive in a node that you want to replace and you don't want that node provisioned until it's replaced. But also you just had that power incident I talked about and you need to lock that node off, even if the data center ops person wants to go replace the drive. So there's a lot of interaction here. And I think we're going to end up with a shape of maintenance that's much, much better, including this ability to lock out the power of a node. But this is one of those things where I think we polished up the idea well enough to find the nugget at the bottom of making maintenance better. And it makes me really, really happy and excited about the possibilities this could open up in the future. So let's keep going. Let's talk about Sushi and async redfish. So if you're not familiar with Sushi, Sushi is the redfish library that Ironic has been maintaining for years and years to talk to redfish machines. It's typically only used by Ironic and other OpenStack projects such as Sushi tools. And what we would like to do is we're going to take that existing third-party library that we've been authoring for a long time and stuff it directly into the Ironic repository. This is going to help us reduce some maintenance overhead. It's going to be one less thing that we have to release, one less thing that we have to worry about syncing up if there's a security backport between. Like there are lots of reasons this is going to reduce our overhead. But one of the bigger ones is it's also just going to eliminate the ability to manage an API to ourselves, right? Like we've got a public library API in Sushi that Ironic's calling. And so if we're able to get both of those in tree together, we don't have to worry as much about that API interface anymore. And it makes things a little more flexible for us. And so we're going to kind of do that first, and then we're going to look at the resulting thing and see how we can utilize async IO in order to get more performance out of things that we have to do in bulk and redfish, such as, metrics gathering. So this is exciting. This is one of those fun technical doors that migrating off of Eventlet has opened. And I'm interested to see if we're going to be able to make meaningful progress on making it better for folks. Most of the rest of these are just sort of, we're getting to the minor updates, and this is good. This makes a lot of sense because we've got a lot of big items up there. And so let's go through these real quick. The little items at the bottom, we've got firmware upgrade improvements. We've had out of band firmware updates for a while on, in typical Ironic fashion. We released a version of it that's sort of minimum viable and have been improving on it as we go. What we're finding is that there are some vendors that prefer us to use different firmware update methods, such as using a push instead of a pull style firmware update. That we've seen that there are some network interface cards that, what shows up in the BMC may not be really consistent, that it may not have all the target properties we expect. So we've got to handle that. The firmware upgrade process itself is one of those decoder rings where when you look at the node, trying to figure out where in the firmware update process the machine is very difficult. And so, we can improve the visibility of that, make it a little bit easier for operators to know what's going on. And then we're also going to reach out and work with the DMTF as we always do to improve the Redfish spec with regards to multi-component update standards. One of the neat things about this is sometimes we're writing a feature with the idea of what people will use. When a feature like firmware upgrades gets to this point, these are actual asks from people running this in the real world. And it gets exciting because we're not just building something that can theoretically do something. We're building stuff that people are using every day and want to make better. And so this is exciting to me. And I almost see when we get to the point of having these specific improvements being asked for, that it's almost a validation of the feature because people care about the specifics of how it works with their hardware now. So that is exciting. Something similar on the improvement side is just improving observability and Ironic Prometheus Exporter a bit. Ironic Prometheus Exporter is a Ironic adjacent tool, which collects metrics from the Ironic cluster and exposes them for fetching by Prometheus. What we're going to try to do is we're going to see if we can eliminate that external service so that you could have Prometheus pull Ironic directly for statistics. Additionally, we're going to kind of add to those statistics as well. Right now, some of that server health monitoring we do through Redfish, it only really returns an okay warning or critical. And we're going to look at providing detail on those outstanding faults. So again, just taking some of these observability features we've added and just teasing them out a little bit, making them a little more useful for folks. PQC and TLS controls for your alphabet soup for the video here. PQC is post-quantum cryptography. And obviously you're familiar with TLS, which is transport layer security. It's how most things are secured these days. And we've had an ask from operators for a long time to provide more granular control over the TLS versions that Ironic uses. And Ironic uses TLS in a lot of places. We talked to the Redfish. We even have options to automatically set up and verify certificates between IPA and Ironic when it stands up. Like we touch TLS in a lot of places. So what we want to do is add controls for that to allow TLS version management, which will then give the operators the tools to pick the ciphers that most people consider safer against quantum computing attacks. So hopefully we'll give people the tools to do that. And if folks are in a regulatory regime that's going to require them to use these post-quantum type of ciphers, they'll be able to. GDisk replacement. So this is one of those that's just a straight up maintenance item. GDisk or SGDisk was originally known as GPT disk. These are the tools that were created when GPT was younger to help manage GPT disks. Now, most of that functionality has been rolled into, well, pretty much every partition and partition modification program in the world now. We don't need a special one, but Ironic's been using it. And what's happened is that upstream is gone now, as far as we can tell. The last release was 2024, and it's getting removed from some software distributions. So we just need to go in there, update the places we're using GDisk or SGDisk and Ironic Python agent, and replace them with uses of other tools such as FDisk or Parted. I think one thing that was interesting that came out of the PTG in this is that we're not sure that one tool will do the job that all of this tool was doing on its own. So that probably is the reason why we kept on it for so long, but we'll get that fixed up so that IPA will keep working for y'all. Another thing that sort of is just reflective of the times is GPU information and inspection. A large number of Ironic users are invested in machine learning, LLM style workloads, and obviously GPUs are really crucial to that. So what we're just going to do is add some basic GPU information to our inspection data, where we'll fetch things like the vendor model, VRAM, other relevant details from that, and store it in our inventory so that you can go fetch that and check it, maybe set traits based on the GPU capabilities, or use our entire suite of inspection rules to act on that information. Another one that we're working on is out-of-band inspection while active. So it used to be that inspection always happened in band with an agent. We booted the Ironic Python agent, ran a bunch of commands, maybe commands that if you're an administrator, you've ran on your own systems, like ls block or stuff like that, ls hardware, ls USB, ls PCI. Look at it, all the things on the machine. But these days, most of that information is actually available via Redfish. And so we've been working a lot on out-of-band inspection. But one piece that's that has been missing, and it's because it didn't really make sense until out-of-band inspection existed, and kind of improved to the point it is now, which is the ability to inspect an active machine. If we're able to do a fully out-of-band inspection, then we should be able to interrogate a machine's hardware without disrupting the instance on it. And that's pretty exciting. The approach we're currently considering is basically taking individual portions of the inspection process and exposing them as service steps. And so that way you could just run a node service with steps that were only non-disruptive inspection steps and get an effective out-of-band inspection while active. And this sort of follows our model of having, maybe high-level automated flows like automated cleaning, which has opinions about what needs to happen. Same thing with inspection now. We're going to have this, an inspection workflow, which is a bigger encompassing thing, but we're also going to part it out so that you can run the portions that you need when you need them, hopefully without disrupting that instance. So that's exciting. This is sort of a blast from the past. The next one here about root disk encryption. We've had some Metal Cubed community members work with us in the past on this, and they're going to come back and pick it back up and hopefully get it across the finish line. This is pretty exciting. So this would just mean that a machine using our direct deploy driver, which just directly images to disk, that you would be able to set up on the fly root disk encryption while deploying that. It sounds really neat. I'm interested to see the shape of the feature when it gets there. And if it's something you're interested in, you might want to reach out and say hello. So last, but definitely not least, is our virtual media, HTTP boot, and PXE enabled cleanup. So if you haven't been around for a while, let me tell you, Ironic's pretty old. The first Ironic release was something like 13 years ago. When Ironic was first released, we didn't have virtual media. It didn't make sense. We didn't have UEFI HTTP boot, or at least, no idea when the spec was written, but in practice, it didn't exist. And so PXE was everything. PXE in the Ironic community, which, by the way, stands for pre-install execution environment, pre-boot execution environment, something like that. While it actually is a very old technology for net booting machines, sort of developed a terminology in Ironic where we meant, the network provisioning port kind of thing, and it got massively overloaded. The fact that I'm struggling to explain it to you right now should tell you how overloaded it is. So, in this particular case, the bug here that was particularly bad is that if you're using virtual media boot, Ironic is still requiring that it's able to successfully bind every port that is marked as PXE enabled. And so this is extra confusing if you're an operator who might have multiple boot interfaces enabled. You might be switching between them and you're getting different behavior based on which one. So that's not great. And the fun thing about this is that it's almost like a knock-on from trait-based networking, which we released in Gazpacho, that causes this. Because when you have flexibility in one part of the stack, you can sort of see the portion that is less flexible and brittle start to bear a little bit more weight and start to be a concerning area. And that's exactly what this is for us. The flexibility that we baked into trait-based networking exposed the inflexibility of our idea of port.pxe enabled. So we have to work to disambiguate the flag. The idea is here, I think, that we want to create a method that would allow operators to be very explicit about what boot modes or boot interfaces they expect a port to be necessary for. I don't know the full shape of that. I do want to revisit what I said at the very beginning and what we kind of highlight here, which is that Ironic contributors are doing a lot of stuff. We're doing things all over the place. A lot of times those can include bug fixes as well, which wouldn't even be listed here. Last cycle, we landed 3 of the largest networking features, I would venture to say, in the history of Ironic. And so this cycle might not be one where we're making as much progress on features as we usually do. We're going to be fixing bugs related to those major features that just went out. We're going to be working on cleaning up things like, you saw here that even a lot of the things we're saying are features aren't that many features. This is definitely going to be a back-end style release where there's a lot of stuff there, a lot of stuff that we're hopefully making better for you, making your life easier. But I don't think there's going to be a big flashy thing to point at for this release. And that's okay. If you're like me, sometimes you like your stuff to be boring. And so that's what we want to do to bring you that kind of boringly reliable experience. And I hope that you find out that 2026.2 is going to be a release that does that for you, that gives you that little bit of boring enhancement a little bit better without adding to the sort of things you got to do. So thank you so much for listening to me here. I do want to say a big thank you to G Research for giving me time to produce these videos, to produce this content for you. If you're in the London, UK area, they do lots of cool stuff there. First of all, they're hiring, so you can go to gresearch.com/vacancies. But also, they have events up there. They have smart folks talking about smart things. And you want to go check out those events, go be a part of it, go join that community. And you can go get to work with some of the really smart people that I get to work with every day as part of Gross. But for now, I'm Jay Faulkner. Thank you so much for your time. Goodbye.